Okay, I got some really good news. I thought I had something going on at 1 o'clock today, but it's actually at 1 o'clock tomorrow. So I can finish the thought I was having in the last video, and that is how does the MED discriminator work exactly? Does it work so that you send the value out to your neighbor and then your neighbor uses that value, or does it work to where the administrator assigns that value to a router and it's only significant to that router? Is it significant to the router it's configured on, or is it significant to the neighbor that the path attribute is sent to? That I don't know. So let's figure that out. Let me do another sketch together demo here. Okay, so let's get sketch together back up. All right, and I will enter in the URL here. Oops, so what is it? DMB _ RW. All right, so I've got the sketch pad up. I should really just make my own one of these somehow, that I don't need to worry about the trials or whatever. But anyways, here's the question I have. So we've got two ASs, and let's just say what AS it is. It's AS 400, and then it's AS 600. Okay, and then we've got in 400 we've got R4. In 6 we've got R6. Now we've got two links, like this and like that. One link has an MED of 10, and it's configured on R4. The other link has an MED of 99, and that's also configured on router 4. We have no neighborships on R6 configured with an MED. We only have router 4. We only have MED configuration on router 4, not on router 6. So here's what we got. So let's first of all take a look at the update packet. Okay, so here's the update messages. So we've got sent to this donation, this neighborship here, and sent to this neighborship here. We have a BGP update message, which is a part of the TCP data payload. And within that message, we have path attributes, and one of the path attributes we have is the multi-exit discriminator path attribute. We have a path attribute of 10 for the update sent to neighbor 10.10.10.2, and we have an update. We have a multi-exit discriminator path attribute as part of the update message to neighbor 99.99.99.2 as well, with a value of 99. So what we're going to try to figure out is what this value actually means. So here we have a route here. We have 4.4.4.4, and we're doing the same route here, 4.4.4.4. So let's take a look at that route, because it's going to show up in the table. So we know, even without knowing how the routers are configured, we know that this is an update sent from router 4 to router 6. We know that for a number of reasons. First reason we know that is because it's including this multi-exit discriminator optional, non-shareable or non-transitive path attribute in it. It's not configured on router 6 to do that. It's only configured on router 4. So if we were to go on to router 6, disable the interface, loopback interface, and then bring it back up, we will not see that path attribute included in the update message. Okay, so here's that path attribute. What? Oh, somehow this happened on router 4, even though I thought I was clicking on router 6. Okay, so here we go. We can see we don't have the path attribute because it's not configured on router 6. So next we're going to focus on how this attribute is actually used. What we're going to do is take a look at the route. So show route protocol BGP 4.4.4.4. This is the route we learned. Aha, so now you can see we have the route in there twice. We learned it from here. We learned it over this link, and we learned it over that link. But we can see that the route that is preferred, that is both the active route and the route that was active last, is the one with the lower MED value. All right, so let's try changing that MED value to be higher. We're going to change it to 100 so that the MED value of 99 is lower, and we'll see if these flip. So let's just do this on a refresh 1, and then we'll change the MED value. Okay, and we'll change the value here. Okay, so the MED value is now going to be 100. Let's see if it flips these two routers. Aha, and we can see, sure enough, as soon as I hit that commit, it flipped it right away. Here's the, here's the flipping right here. We see before I had that changed, the preferred path was over the 10.10.1 link because it had an MED of 10. Here, this is the last time we checked that command before I changed it. And then in under 1 second, it received that update, and now it's preferring the one over 99.99.99.1 because it now has a lower MED. It prefers the MED 99. So you can see it does, my whole thing that I thought was mostly false is actually true. Like that's how it works. If I were to send a route, if I were to take a look at for example, a route to, so show route protocol BGP, you can see I have 2 destinations, and I have this destination preferred, but I don't have a multi-exit discriminator value for any route in my BGP routing protocol. Now that might seem weird because I configured a multi-exit discriminator value, so why don't I have any multi-discriminator values in my routing table? If let's take a look. So show configuration pipe display set pipe no more. There we go. I've got multi-exit discriminator values configured, but I don't see any multi-discriminator values in my routing table. What gives? Well, what you're doing when you configure a multi-exit discriminator, the multi-exit disk attributes, which we can see in the update message, I think. Yeah. Right here, multi-exit disk. That's how it shows up in the actual RFC. We see that is actually being sent out from this router here. So it doesn't apply to this router. It applies to this router. And the reason for that is because it's being sent to that router in an update. So you might think that the way this works is that you now, because the way almost every other piece of configuration works, this is BGP, this is different though, is I apply an IP address to interface GE000. GE000 should have that IP address, right? Of course, that's the way it works. It's just not complicated. But where it gets complicated is when you configure BGP, because you say, I applied metric 100 to this neighborship. This route is has a choice between these two neighborships. And you can see it's preferring the link to it's preferring the neighborship here, which is to 10.10.10.2, over the neighborship I configured to have a lower MED. So that doesn't make any sense, right? Because I told the link 99.99.99.2 to be preferred by on router 4 by configuring router 4. Not how BGP works at all. You didn't tell router 4 to prefer the route. You told your neighbor to prefer it. So what I said rings true. These are separate autonomous systems. I cannot log into router 6. It's probably located in a building that is very securely locked down. I have no access to that. You're not going to give me any passwords, anything like that. But I can essentially configure your router by sending you an by sending you a path attribute in my BGP update message. So I send you a path attribute, which is the multi-exit discriminator path attribute. It's a non-shareable attribute, so you can't share it with other autonomous systems. You can share it within your own autonomous system, but not amongst autonomous systems. And what this value says is prefer this neighborship, which is different than the next hop, because you can form neighborships across multiple hops. But prefer this neighborship over a neighborship with a higher MED. And I think it also means prefer it over a neighborship with no MED, but I'm definitely interested in trying that. But you can see here, we've got MED values. Here we do not, even though that might seem a little bit counterintuitive, because I configured MED values here. Well, yes, you configured it here. Here it is in the config, but you didn't say on router 4, use an MED value of 199. What you said is on router 4, in your update messages that you send via BGP, include a path attribute called the multi-exit discriminator that tells router 6 which link it uses to send traffic back to me, router 4. So that's how the multi-exit discriminator value works. It's for eBGP connections, and it's a way to tell a router you don't have access to and cannot configure how to send you the traffic. So if I were talking to someone else and I said, I could tell that person, hey, here's a card. Please put something, or here's how do I say this? Oh, I could reach out both of my hands to shake hands, and I could say, please shake my right hand, and they would shake my right hand. But that thing I said, please shake my right hand, that's a multi-exit discriminator, because they have two ways of shaking your hand. If you hold out your hands like this, they can reach across with their right hand and shake your right hand, or they can reach across with their left hand and shake your left hand. They have multiple exits, way to put out the action of shaking hands. They can exit that action from themselves by shaking with their right hand, or they can exit that action of themselves by shaking with their left hand. So if I just put out my hands and I don't say anything, there's no discrimination to the way they exit their handshake from themselves. They can do whatever they want, and I'm not sure what it does by default. I'm sure it does something, but I'm not sure. But if I say to them, please shake my left hand, I've given them a multi-exit discriminator. So they have two ways of shaking my hand, with their left or their right, two exits of the action of shaking hands, but I've given them the ability to discriminate amongst those exits, right hand or left hand, by telling them to use their left hand. So now, in order to have them shake my left or my right hand, let's say my left hand, I have to be the one with the configuration. I am the one deciding which hand they need to shake. So that's what the multi-exit discriminator is. If I were talking to someone else and holding out both my hands and said, please shake my right hand, I would be sending them that message, please shake my right hand, and that message would be a multi-exit discriminator for them. Because if I didn't send that message and I went like this, they would say, what are you doing? Or they would make a decision and choose one of your hands to shake on their own. But if you give them and this is a way they could, and shaking your hand is exiting that state of not knowing which way to shake your hand. So when they exit that state, there's no discrimination about how they do that. So there's no multi-exit discriminator if you just go like this. So if you go like that and you say, please shake my right hand, now you've given them an exit discriminator, and they say, oh, well, to do that, I do my right hand like that. That's how they use that attribute you gave them, please shake my right hand, to discriminate amongst which hand they reach out to shake both of your hands that are reached out. So I think I've got a good understanding of this now. It's complicated. It's a really complicated thing. It's kind of no surprise that I had such a poor grasp of it. But for me, the key things to understand are, one, that when this is configured on A, and there's a connection from A to B, the action is taken on B, even though the configuration is on A. And that's not exactly correct, because it depends on what the action is. If the action is sending out a multi-exit discriminator value, then the action does occur on A, where you make the configuration. But if the action is the response to the multi-exit discriminator value and the routing decision based on the multi-exit discriminator value, that happens on B, even though there is no configuration on B. There's only configuration on A. The BGP protocol itself knows how to handle a multi-exit discriminator value, but whether or not it receives a multi-exit discriminator value in the update message depends upon the configuration on A. So whether or not B receives a multi-exit discriminator value and makes routing decisions based on that value depends on the configuration on A. And that makes a lot of sense, because if you think about it, BGP is meant to be used across autonomous systems. And an autonomous system is something that belongs to a particular zone, an autonomous zone. So if there are multiple autonomous systems, they are not meant to interact with each other. They're meant to be held separate. So if I don't have access to your autonomous system, for good reason, you don't want me in there, and I need, and we have a connection, and all of a sudden something happens where, oops, this connection went down, I can't get you on the phone, I can't do anything. How do I make sure that my routing decisions are made the best for me? I send you a multi-exit discriminator value, and without even having to call you or access your equipment, I can make sure that your routers, let's say that there's a third link. Oops, I had there we go. So there's a third link here. Let's say this link goes down, and now you've got two links to choose from. And I want to make sure you choose this link. I send you a multi-exit discriminator value of a lower value for this link and a higher value for this link. And without having any access to your gear, without having to call you in the middle of the night, I make sure that the behavior your router is doing is the appropriate behavior for my autonomous system. So, you might think, oh, well, that has its own security problems. I don't want you to just use the MED value on my routers and change all my routing. Like, if you're gonna do something, I might want it to be a part of that process. And if we agreed that the black link here is the link we were meant to use, but then you use this one, like, that's a problem. So there are things you can do, from what I understand, because this is where it says, if received over eBGP, the multi-exit disk attribute may be propagated to other. Okay, so this is different. Yeah, so here we go. An implementation may also, based on local configuration, alter the value of the multi-exit discriminator attribute received over eBGP. So I can say, I know what you're gonna do, I don't like it, if this link fails, tell me to use the blue link instead of the black link, so you're gonna send me a multi-exit discriminator of 10. So what I'm gonna do is take your discriminator value of 10 and bump that up to 100, because I know you're gonna do that and I don't want you to do that. So this is what I'm going to do is make sure that you can't do that. So yeah. So it's up to the network engineers responsible for their separate autonomous systems to coordinate and work with each other and come up with a way that their traffic can be exchanged, but that doesn't always require a static set architecture. You can set it up so that, hey, if you've got a problem, you don't like it this way, just send me a new MED, and I'll configure my routers to respond to that MED in a way we agreed upon and you expect. Okay, so I think that's it for the MED. I think have a good understanding of that now. I now understand that the configuration that goes on router 4 actually affects the decisions made by router 6 and not router 4. I didn't understand that. I also understand really clearly now that the lower value is the one that's preferred. I kind of had that confused. I didn't know whether it was one or the other. And then the other thing I really understand a lot better about MEDs is it affects a route and not a neighborship. So you can see where we're exporting routes into BGP, so that gets sent through these neighborships here. So if I were to do a show BGP neighbor, I won't see that MED value in here. So pipe match 99. Yeah, there's nothing in here. This output here that has MED in it. That's just not a part of the neighborship, and that's a misconception I had. I believed it to be preferring one neighbor over the other, which is kind of true, but you've got to be careful when you say it prefers one neighbor over the other, because that's not true. It prefers one neighbor over the other depending on which route or set of routes you have given an MED attribute to. So you can see here we've given an MED attribute to all routes sent to this neighbor in this export. We can also give it to all routes tagged with a specific community string, or we can give it to specific routes, and by doing that we give it to specific routes sent to a neighbor. So it's not that it prefers one neighbor or the other regardless of the route. It's that depending on which MED value the route was assigned, and there are multiple ways to assign it, you can assign it just purely based on one neighbor or the other. It prefers one neighbor or the other. Okay, so let's move on to local preference. Local preference is a well-known attribute that shall be included in all update messages that a given BGP speaker sends to other internal peers. A BGP speaker shall calculate the degree of preference for each external route based on the locally configured policy and include the degree of preference when advertising a route to its internal peers. The higher degree of preference must be preferred. And this is different from the multi-exit discriminator, where the lower metric out, which is another term for multi-exit discriminator. It's the term that Juniper uses for their command set. In that case, the lower is preferred, but for the local preference, the higher is preferred. A BGP speaker uses the degree of preference learned via local_pref in its decision process. See section 9.1.1. A BGP speaker must not include this attribute in update messages it sends to external peers, except in the case of BGP confederations. If it is contained in an update message that is received from an external peer, then this attribute must be ignored by the receiving speaker, except in the case of BGP confederations. So this would be a good RFC to look through as well. Another good one would be RFC, and then they're called route reflector. Yeah. Okay, so section 5.1.6, atomic aggregate. Atomic aggregate is a well-known discretionary attribute. So here's a new term, discretionary versus non-discretionary. Now it's a well-known attribute. So this is where my suggestion for the language of well-known versus optional be replaced with required versus optional breaks down, because a well-known attribute isn't always required. So I kind of have to rethink of that. I still don't like the terms well-known and optional, because I think they're not correct. But it's definitely better than what I came up with, required and optional, because it's not actually required. So well-known and optional is makes more sense. I guess a better thing would be standard and standard and custom, I think, would be better words for this. So it's a standard discretionary attribute versus a custom discretionary attribute. So let's make a drawing here of the terms that I would like changed when it comes to BGP, because the current terms just don't do it for me. They're really confusing, and they lead to a lot of misunderstandings, I think. So we're gonna take the first one. This is very clear. So transitive. I think transitive should be shareable. And then non-transitive. I think that should be renamed to non-shareable. Okay, and similarly for the language well-known and optional, I think those need a new name as well. So let's write down well-known. So I think well-known needs to be renamed to standard. And I think optional needs to be renamed to custom. Because those are clearer terms with meanings that the general public, people who are not specifically studying BGP, that are more clear when you consider the concepts behind these BGP specific terms. So even though the term that is specific to BGP and that all experts in BGP will understand and be familiar with is transitive, I believe that a term that won't make sense to experts in BGP, at least not right away, that is more clear in what the concept actually is the term shareable. I think that's the case for the well-known and optional. I think more clear is standard and custom, but we will see as I learn more about this. So let's, before I move on to atomic aggregate, let's look at the local preference. So the local preference, so this is an eBGP connection, so we don't have the local preference. It looks like the local preference is a optional, sorry, it's a well-known attribute. So that I would call a standard attribute. Okay, now this is interesting. So it looks like a well-known attribute isn't required in a BGP update message. Like, I thought that's what a well-known attribute was, an attribute that's required in a BGP update. But we can see that local preference is well-known, but it's obviously not required because it's not included in this message. So let's go back to where I initially read about local preference. So okay, so let's write down some more terminology here. The other, so we've also got the terms mandatory, discretionary, and required. So let's write down those terms as well, because they are in the RFC. And we'll think of better words for those. I think that's the key to learning BGP, is coming up with new terminology for it, because the current terminology, I think, just is not clear enough, and it doesn't match the concepts. Like the mathematical and colloquial grammatical definitions of transitive don't mean what is meant in the context of BGP. It means that like, it doesn't mean that you can't share it amongst other ASs. It means something else than that. It's not even related to that. Like, transitive just isn't the correct word to use for the concept they are describing. I think sharing is like a better word. Okay, mandatory. Discretionary. And we also got required, which is an interesting word to see on there, because that's a word that I thought would be better than the word well-known. But clearly I can't use that in place of the word well-known, because it is already a word included in this RFC. Okay, so let's go back and read about the 4 categories of path attributes. The first category is well-known mandatory. The second category is well-known discretionary. The third category is optional transitive. And the fourth category is optional non-transitive. So let's break those down and try to rename those. So I'll move this over here. Okay, and then we're going to do the first one here is well-known mandatory. Okay, so now it looks like I already have names for this, but I don't have names for mandatory and discretionary. But what I do see here is that we've got, and let me map this out actually. This might really make things clear here. So we've got 4 different kinds of path attributes, right? And I don't know, okay, there we go, yeah. We've got the well-known mandatory path attribute. We've got the well-known discretionary attribute. We've got the optional transitive attribute, and we've got the optional non-transitive attribute. So basically we've got 2 main types of path attributes. We've got well-known and we've got optional. So let me draw that. So here's well-known. And then here's optional. These are 2 separate things. Then we have mandatory, which is a part of well-known. So mandatory goes in there. So let me hopefully make this clear. So here's well-known. And then within this, but separate. So let me draw it as a tree. I think that might be the most clear. Okay, so these are path attributes. Path attributes. So there's two kinds of path attributes, primarily. I got 20 minutes in the trial here, but that's okay. I can just make a new one. There's well-known. And there's optional. Okay, and then each of those have two as well. There's mandatory. And there's discretionary. Okay, and there's mandatory and there's discretional well-known path attributes. There aren't mandatory and discretionary optional path attributes. That's not true. Okay, and I'll make this a bit longer so I have more space. I think that'll be clearer if I do that. That won't make it less clear. So I'm going to make this arrow go down a little bit farther just so I have more space to write. And then the optional are transitive and non-transitive. Okay, so let's try to come up with new terminology for this. So path attributes, I think is a good, fine enough word. I don't think there's a need to come up with new terminology for that. It's clear enough to me what a path attribute is. We can see in here we have our path attributes tied, and that's on top of our network layer reachability information. Now, if I were to, one thing that might be interesting is if I were to go on 4.4.4.4 and edit interface LO0.0 and set another address on there, 44.44.44.44/32. And commit that, now we'll get another update message. But one thing we'll see, I believe, unless I'm mistaken, I could very well be mistaken. So we should see a update message coming through. Oh, never mind, because we've got a route filter here, so it won't include that other one. It'll be filtered out. So we've got to update the route filter as well. Okay, so now we should have terms 1, 2, and 3. Term, oh. Yeah, I don't think this is going to work. I don't think I understand what terms are well enough. Why is it not allowing? It looks like it's not allowing term 1. Because where's 4.4.4.4? Looks like term 1 isn't being allowed for some reason. And I wish I understood that better. Why is it not allowing term 1? That makes no sense. Is it because it's the longest match? And that's a longer... No, because it would be a match, right? Like if it's a 0, matching a 0, it's still a match. Why does it not take... First of all, why doesn't it order them the way I think it would order them? I mean, I can't have two... Here, let me try this again. That did not work. Okay, now let me do a edit policy options prefix list. Okay, here we go. So prefix list, advertise to 600. Set. Okay, so now we can set our prefixes in here. There we go. Set. Okay, and now we can make a term where we do set to 600 term and let's see, let's think of a good name for the term. Call it term send routes. Okay, and then we'll say from. Okay, so we're gonna send routes from prefix list, and then I named it advertise to Bgp 600. Okay, and then we're going to send routes to protocol BGP, and then we're going to send routes then accept. Okay. Oops, and I need to change. Yeah, I need to change the. Okay, so now this is called 2600 export. So this is a much better naming. You can see if I do a show pipe display set, and I go through this policy, and I can do a edit policy options and then do a show pipe display set relative so it all fits on the screen there. But you can see I've got a prefix list named advertise to BGP 600. So here's the routes I want advertised over to BGP AS 600. And now in my policy statement, we've got, it's named to 600. Term send route. So this is much better than 1, 2, and 3. It's clear what this term is meant to do. It's meant to send the routes. So we're going to send the routes from this prefix list here, advertise to BGP. We could also name this eligible routes list or something like that, just so this reads like an English sentence. And then we're going to send it to protocol. And now here's where it's a bit counterintuitive. I do think you need this, otherwise it's an automatic reject. But we'll try that. Yeah, I'm going to do a. I'm going to make sure this is live capturing, and then I'm going to commit that, and we'll see an update message. There we go, and it goes across both links because remember we have an MED. Oh, and the other thing is this is not this is our update message. This is not a routing decision based off our update message, so it's going to go over both links. Well, not regardless, it would go over both links depending on how our neighbor looks in the BGP table. So if I do show Bgp Summary, I can see my neighbor is, I've got 2 neighbors. So let's take a look at each of those neighbors. So show route. So we've only got, it's a directly connected route. It's out GE000. So we've only got one choice for that. Same for this. And it's not a BGP route, it's a directly connected route. So it's not going to have a multi-exit discriminator value with it. So for our BGP update messages, they're always going to be set out both links, even if I were to set up an MED on router 6. Because those are different kinds of routes. They're directly connected routes, and you can make you can toggle that. You can make them BGP routes if you toggle things. Well, actually, I don't think you can change the AS on directly connected routes. Maybe you can, but that would break a lot of things. That would be a bad idea. Yeah, now that I understand the MED value better, that's more clear to me now. Router solicitation. Oh, IPv6. What the hell? Why was there? There's no IPv6 anywhere. Let me stop live capturing, or live scrolling rather. We'll keep live capturing. So there's an update for withdrawing routes. Should be an update for adding the routes, right? I thought there would be more than just those 2. I guess you don't need to, I guess because I had already learned. Wait, why did it withdraw those routes? It should still have those. What the heck? Let's see what routes it has. Oh, it doesn't have any. What the hell? Okay, so we're exporting the 2600 policy statement. Oh, maybe I need to remove this. I don't know what this means. Huh. Yeah, I don't think I need this statement. See, this is another thing that's really unclear to me that I need to figure out. So hopefully this can be a part of this series is figuring this out, because this is really unclear to me. Okay, but hopefully we got an update message. Yep. So, okay, this is what I was expecting to see. We've got the multi-exit discriminator value sent along with these because we've got the configuration here. But again, it's not used by R4, it's used by R6, and we can see that in the routes it received. It uses it to prefer the lower valued path, BGP path over the higher one, because it's got two choices here. It can go over 9 or 0, but it's going to go over 9 because this path has a MED value of 99, which is lower than the other path, which has an MED value of 100. If I set the path, if I set the MED that will be received to have a lower number for the path through 10.10.10.2, then that will be the preferred path. So let me do that quick. Okay, so we'll get an update message. Here it is. And you don't need to send a withdrawn message. We learned that from the RFC. You can just overwrite the information if there's new information. So we overwrote the multi-exit discriminator value for both of these routes because both of those routes are exported to both of these peers. We can make the export policy apply only to one peer. In that case, it would not be that way. Let's try that just for. But here we can see they're flipped. So I have a much better understanding of the multi-exit discriminator value now. So if from router 6 I were to ping 4.4.4.4, we would see that going sourcing from 10.10.10.2. See how that works? But in router 4, if I were to ping the loop back on router 6, 6.6.6.6, we can see that sourcing from it sources from 10.10.10.2 because that's the highest path in there, and we can see there's no MED value, so it did not use that. I'll admit I thought it was going to source from both of them because I'm still kind of dumb when it comes to this stuff, but it did not use the MED value to determine which to source it from. But yeah, it just sources it from one link. I'm not sure why, because I thought you could have cost equal paths that it would load balance across. I don't understand. I don't understand what's going on. I'm a little bit confused right now, but we can see on this side, it's making the decision, as we see here, as to which source address to use based on the MED value. So let's look at that one more time. If I'm pinging 4, we can see in the packet capture the source is 10.10.10.2, but if I send it a new MED value, okay, so I sent it a new MED value, we'll get an update. Here it is. Yep, so here's the new value of 100. Let's take a look at the routing table. Yep, now the 99, the 99.99.99.1 source IP is preferred. So if I ping it, there we go. We've got a lot of ICMP traffic sourcing from that source IP. I got a message. Let me check it out. Oh, okay. Oh.
Yeah, I don't know about that.
Okay, so let me think here. Let me think. Oh, okay. So yeah, hopefully that's clear. Let me know in the comments if it's not or whatever. If anyone's watching, it's not what we're in right now. Let's go back though to what I was discussing before. I've only got 10 minutes left on my drawing here, but oops, actually I lost it. So let's go back to thinking about these path attributes and coming up with a better way to describe them. Okay, so I'm going to write that out again. I think that was useful. We've got path attributes. And let me put that over on this other side here. Oops. There we go. Okay, and then we've got two kinds of path attributes. We've got well-known path attributes. And we've got optional path attributes. And we've got two kinds of well-known path attributes. Okay, let me make this easier to see. So we've got mandatory well-known path attributes. Okay, and then we've got optional well-known path, we've got discretionary well-known path attributes. Likewise, we have two kinds of optional attributes. We have transitive, and I really think a better word for transitive is shareable. So we have shareable optional attributes, shareable within the autonomous, shareable across autonomous systems. And then we also have non-transitive attributes, which I believe a better term for is non-shareable. Non-shareable across autonomous systems, even though they are shareable within the autonomous system. Okay, so we've got a total of 4 different kinds of path attributes. So if you have a path attribute, you can have either an optional or well-known path attribute. And if you have a well-known attribute, it can be either mandatory or discretionary. If you have an optional attribute, it can be either transitive or non-transitive. And that is, so let me use that new term. If you have an optional attribute, it can be shareable or non-shareable. But where I'm confused is I thought well-known attributes. Okay, so here's a list of, let me see here. So the mandatory category refers to an attribute that must be present in both. What the hell? This doesn't mean anything. the mandatory category, so this category here, the mandatory category, which means that it's a well-known attribute, refers to an attribute that must be present in both iBGP and eBGP exchanges if network layer reachability information are contained in the update message. Attributes classified as optional, so in this category here, for the purpose of the protocol extension mechanism, may be purely discretionary. That's not true. It says here that, see, this is why I made this drawing, because I thought I was going insane. It says here that optional can either be transitive or non-transitive, but it can't be discretionary or mandatory. That's literally what it said up here. It said that. Okay, so here it's explaining it a little bit better. So BGP implementations must recognize all well-known attributes. So if it's a well-known attribute, it must be recognized by BGP. MED is not a well-known attribute, it's an optional attribute, and it is non-transitive. But it doesn't have to be recognized. So the drawing I made before, and the one thing that can happen, that's okay, is I put out both my hands, I give you an MED, shake my right hand. That's a multi-exit discriminator. You've got 2 ways of shaking my hand, of exiting the action of shaking my hand from yourself. You can exit that action using your right hand or your left hand, but I gave you a discriminator, the phrase shake my right hand, so you shake my hand with my right hand. The other thing you can do, according to this RFC, is just say, what are you talking about? That's not how people shake hands. If you want to shake my right hand, hold out your right hand and leave your other hand at your side. So you can not recognize the discriminator I gave you, and just not refuse to shake my hand, because that's just not normal. What are you doing? And that's because it's an optional path attribute. You have the option to not recognize it. But if I were to say to you, here's my origin, here's my AS path, and here's my next hop, and you were to say to me, what are you talking about? You would be violating the rules of this RFC. You must know what those mean. You don't have to know what a multi-exit discriminator is. After you get those things, you can say, that's a weird way to shake hands, I don't want to do that. But you've got to recognize well-known path attributes. Oh, I see. So that's the difference between an optional and a well-known path attribute. So well-known path attributes are going to be origin, AS path, and next hop. And if there were 2 people talking to each other, and I say, hey, this is my origin, AS path, and next hop, and you say, what the heck are you talking about? You are violating the IRFC. You must know what those mean, otherwise you don't have a proper implementation of BGP. Because those are well-known attributes. They have to be known. You have to know them. The other option, or sorry, the other branch in this tree of path attributes is the optional, and that's the MAD. I say, shake my right hand, and you say, no, why are you doing this? That's crazy. I don't know what you're talking about. So you have the option to respond that way, to not have a recognition of the multi-exit discriminator path attribute. It's an optional attribute. A router doesn't have to have that in their implementation in order to be properly running BGP. Okay, but it goes a little bit more than that. Now, the difference between a mandatory and a discretionary well-known attribute is for a mandatory well-known attribute, if I say, here's my origin, here's my AS path, here's my next hop, you must say, I know what you mean by origin, AS path, and next hop. Because those are well-known attributes, you have to know what they mean, otherwise you are not properly participating in BGP. But what you can say is, here is my origin and my AS path and but I'm not going to tell you my next hop, assuming the next hop is a discretionary well-known path attribute. I don't know that, but let's just assume for the sake of this discussion that it is. I can say, I'm not going to tell you what my next hop is, even though it's a well-known path attribute and I know that you know what a next hop is. So I know that you can, I know that you know what I mean if I say, here is my next hop, because it's a well-known path attribute, so you know it. But I don't need to tell you because it's discretionary. And that's opposed to a mandatory well-known attribute where I know that you know what I would mean if I tell you that, and I have to tell you that because otherwise I would be violating the BGP standards. So that's the difference. I have to tell you, and I know that you know it, versus I don't have to tell you and I know that you know it. That's the alternative to the optional path attributes, which are always discretionary. Optional, all optional path attributes are discretionary. I can either tell you an a optional path attribute or I don't have to. They're all discretionary. So it's kind of, I guess a better drawing would be like drawing a circle around this, because all optional path attributes are discretionary. I have the ability to send them or not send them and still be following the BGP protocol standards. That's different from a mandatory well-known attribute. If I don't send you a mandatory well-known attribute, I'm violating the standards of BGP, and there's going to be a problem. Okay, so optional transitive, that's a path attribute that is shareable. You can send to other ASs, but I don't have to tell you about it. I can choose to send you that attribute, or I can choose not to send you that attribute. A transitive optional path attribute is also discretionary. Similarly, a non-transitive optional attribute, an attribute that you can't share with other ASs, although you can share it within your AS, I also don't have to send you in an update. I can either send it to you or not send it to you. That is that is something I can choose to do or choose not to do, and that's discretionary. So basically these words here, optional and discretionary, mean the same thing. When you say the word, oh, no they don't, no they don't. They don't mean the same thing. So what the word optional means and what it means differently than discretionary is optional means that I have the ability as a manufacturer of a piece of equipment that runs BGP to allow this equipment to not understand what an MED is, because an MED is an optional path attribute. I can do that if I so choose. I want to save some CPU processing or something like that, and I just don't think an MED is going to be really essential. It's just not a feature I'm going to offer. I can do that because it's an optional path attribute. Now, a discretionary well-known path attribute is a lot different. You can't do that. If you're a equipment manufacturer, you have to include the discretionary well-known path attribute. The difference between the word optional and discretionary is in a discretionary well-known attribute, path attribute, although your equipment has to know about that path attribute and have it be written in the code, when you send an update, you have the discretion or the choice to send or not send that path attribute. But the device itself must have the ability to send and receive that update, even though it has the ability to choose whether or not it sends and receives it. But once it is received, it's required that the device be able to read it, and the device is required to have the capability to send it. For an optional path attribute, the device does not have a requirement to be able to read that path attribute and does not have a requirement to be able to send that path attribute. Now, if you make a decision as a manufacturer to build a device that does include optional path attributes, now you have path attributes that are optional, that are shareable and non-shareable. If you make a device, you don't have the choice for well-known path attributes. You have to have that included in your operating system for that device. But for certain path attributes, for discretionary path attributes, discretionary well-known path attributes, you can choose when to include them in your update messages. But if you don't include it in your update message, your device must still have the ability to include it in its update message, and certainly have the ability to read it if it is included in a received update message. Now, this is different from a mandatory well-known path attribute, where not only must your device be able to send and receive it, your device must send and receive it anytime there is a BGP update message. So the mandatory well-known path attributes are the origin, the AS path, and the next hop, I believe. Let me check my knowledge on that. Yes, so those are the big ones. Those are mandatory, and these are all, let's see here. Yeah, so the three big ones are the origin, the AS path, and the next hop. Those are the mandatory well-known path attributes. Anytime you see a BGP update message, you will have a BGP update message that contains path attributes. Not all BGP update messages contain path attributes. We've seen that withdrawn, that BGP update messages that have withdrawn routes do not require path attributes. Only update messages that include network layer reachability information require path attributes. And even then, the only attributes that are required to be sent in that message are the mandatory well-known path attributes. But there's only three of them. There's the origin, the AS path, and the next hop. Multi-exit discriminator, we've seen Now that's a discretionary, well-known attribute. So I was wrong about that. It's not an optional path attribute. It's a discretionary, well-known path attribute. So if you're building a device, you must have your device be capable of reading a multi-exit discriminator that was sent to it in a path update, in an update message as a path attribute. But when a neighboring device sends it to you, or sends a BGP update message containing an LRI to you, it does not have to be included in the path attributes because it is discretionary. But even if it's not included, your device must be capable of reading it if it were included. And that's because it's well known. For optional path attributes, that's not true. So origin, that's the big one, well-known mandatory. AS path, big one as well, well-known mandatory. Next hop, another well-known mandatory. Those are the big three. Every update message with an LRI are going to have those three because they're mandatory well-known path attributes. Okay, so the next one is O. See, that chart makes no sense because, see, I thought this was an optional non-transitive attribute because it says it's an optional non-transitive attribute. Up here it says that it's a discretionary attribute. So, and discretionary is well known. So there, I wonder if this is part of the errata. Yeah, the errata exists. So let's look at the errata because I bet you this is part of the errata. Like that chart should be in the errata because that's just not right. I would expect this. Oh, where was that chart? But anyway, I would expect that chart to be in the errata. There's a lot of errata in this. Is this it? No. Oh, that's interesting. Oh, no, this is rejected. That's not, this isn't true. Yeah, see, this is where it's getting confused though, because if it's a mandatory, no, see, local preference should be they say what it is. It's a well-known, oh, wow. Yeah, I mean, if it's a well-known attribute that shall be included in all update messages, it sounds like it's a discretionary well-known attribute. Like, I don't know why they can't just say that, because they said that for other things. Yeah, they say this is a well-known mandatory attribute, so, and then they defined a discretionary attribute as an attribute that shall be included in messages. So I don't know why they don't just say that this is a well-known discretionary attribute. And I see why the person submitted an errata for that, because it's just so unclear. Yeah, section 5 defined, yeah. Yeah, this is so confusing. Okay, so here's the verifier notes. This is, we'll see why this was rejected. What the hell? Okay, I don't understand that. It looks like he's talking about the open sent to idle event on event 18 at that point. I don't know if that's even a response to this, to be honest. Yeah, it looks like this wasn't responded to. Oh, I guess it was responded down here. I don't know. What the hell? It says that a well-known mandatory attribute would result in a notification message. But I thought not including a well-known attribute, mandatory attribute message would result in a notification. This is very unclear. This is kind of upsetting. Like I really, to be honest, like am not understanding a lot of things when it comes to BGP, and it's looking more and more like it's not me. But I understand more than I did before through this series. But I definitely don't understand these 4 categories because, you know, they define very clearly what a well-known discretionary attribute is, but yet they're saying that local preference, even though it fits that definition, is not a well-known discretionary attribute. They're calling it a well-known attribute that shall be included in all update messages. What? Oh. Yeah, so to me that would be a well-known discretionary attribute, but it looks like they're calling it a well-known attribute, which I understand that errata, if they're calling it a well-known attribute, then there should be 5 categories of attributes: well-known, well-known discretionary, well-known mandatory, and optional transitive, and optional non-transitive. Because you can't have a optional attribute, path attribute, without it being transitive or non-transitive. But it sounds like here you can have a well-known attribute that is neither mandatory nor discretionary. But I would consider this to be discretionary. I just think they made a mistake. In fact, I'm gonna submit an errata for this. That would be cool to get my name in the BGP stuff. How do I submit an errata? I don't know how to submit an errata. Port new errata. RFC number 1. Port new errata. Port new errata. It's probably editorial. Section. Uh, 515. Discretionary. Yeah, this is correct. Now, here they have, why is everyone so confused over this? Here they have in slide 3 mandatory attributes, and as an example they show local preference. Discretionary attributes, they don't have that. But here on slide 4, they have a classification of BGP attributes, and in well-known mandatory, where on slide 3 they had local preference, on slide 4 they don't have it under the same section, they have it under well-known discretionary. And from reading the RFC, I believe it to be a well-known discretionary attribute, and I believe that changing this sentence to say local pref is a well-known discretionary attribute that shall be included in all update messages will make that more clear. It is unclear what kind of it is unclear from the text which of the 4 path attribute categories local pref belongs. It is unclear from the text to which of the 4 path attribute categories local pref belongs. It looks there was even submitted an errata there was even submitted an errata to create a 5th category for this attribute, but it is clear from the definition of the categories that this attribute is well-known discretionary. Is well-known discretionary. How do you spell discretionary? Up here. Okay, is well-known discretionary. All routers must be capable of processing the local pref attribute all routers must be capable of sending or receiving the local attribute. However, it is to the router's discretion whether to include that attribute in an update message. Is that not how you spell discretion? Can we please, can we re-spell words? Am I pronouncing this wrong? Discretion. That's how you pronounce discretion, right? So why isn't it spelled that way? Is there too many S's? This says discretion. I mean, like, why can't we just respell certain words? Like, this clearly says discretion, and this is how you spell discretion. I guess you could say discretion, like scissors, discretion. But sometimes I just think words are spelled incorrectly. It's not that I'm spelling a word wrong, it's that the word is spelled wrong, and I'm meant to know the incorrect spelling of that word. I definitely feel that way sometimes. Oh, WHETHER. Okay, it is unclear from the text to which of the 4 path attribute categories local pref belongs. There was even submitted an errata to create a 5th category for this attribute. But it is clear from the definition of the categories that this attribute is well-known discretionary. All routers must be capable of sending or receiving the local pref attribute. However, it is up to the routers, up to a router's discretion whether to include that attribute in an update message. And 6, so that would be 13. Let's review that, and let's, this would be the hardest thing to, if I lost, so let's just put that on my clipboard. And then review. Okay, so this is how the record would look after adding it to the database. If this is correct, please submit the report. So we would have an editorial type, and then section 5 says local pref is a well-known attribute that shall be included. And it should say local pref is a well-known discretionary attribute that shall be included. And then notes, it is unclear from the text to which of the 4 path attribute categories local pref belongs. There was even submitted an errata to create a 5th category for this attribute, but it is clear from the definition of the categories that this attribute is well-known discretionary. All routers must be capable of sending or receiving the local pref attribute. However, it is up to a router's discretion whether to include that attribute in an update message. Perfect. Submit this report. Okay, my name might be in the official BGP RFC errata section if this is approved. That would be, I'm putting that on my resume if that's the case. And I hope it makes it in there because I think I'm right about that. I mean, it might even appear in there as a rejected errata, and even that would be pretty cool because hopefully I'd get a explanation back that would really clarify that for me, because if I'm not understanding it from reading the actual RFC, it's just not understandable. Like, I'm sorry, like it's just not a clear enough concept or expressed clearly enough. Which, I mean, I'm kind of surprised that yeah, so I don't know. But aggregate is a well-known discretionary attribute as well. So okay, let's read this. So local pref is a well-known discretionary attribute if they accept my errata. If they don't, then it's a well-known attribute, whatever that means, that shall be included in all update messages that a given BGP speaker sends to other internal peers. A BGP speaker shall calculate the degree of preference for each external route based on the locally configured policy and include the degree of preference when advertising a route to its internal peers. The higher degree of preference must be preferred. A BGP speaker uses this degree of preference learned via local pref in its routing decision process. See section 9.1.1. A BGP speaker must not include this attribute in update messages it sends to external peers. except in the case of BGP configurations. If it is contained in an update message that is received from an external peer, then this attribute must be ignored by the receiving speaker, except in the case of BGP configurations. Okay, so basically the local preference is just like the multi-exit discriminator. One of the main differences is it's well-known versus optional. So if you build a networking device, it has to know what a local preference is and how to process it. Multi-exit discriminator, you don't have to include that in there if you want to save processing power or whatever. I'm sure there's a reason a networking manufacturer wouldn't build that in there. And that's because it is optional. Local preference is well known. So from what I understand, that's the difference between those two terms. The other difference is local preference is discretionary. So a router can choose to send it or not send it. So and remember, all optional path attributes are discretionary attributes as well. A router can choose to send it or not send it. I think it actually might not be that way. My working understanding of that is that is true. But I could see a case where you have an optional attribute that must be, like, let's say I have my own networking company and I'm building routers that run BGP and that have custom optional attributes in them that are only able to be processed by my specific brand of routers. That's why you should buy my routers over the other ones, because they have an extra BGP optional attribute. I could make that mandatory and say, if you're going to use my routers for BGP, my implementation of BGP requires this optional path attribute. So therefore mine aren't interoperable with other vendors. So I don't know why I would do that, because I think nowadays if you're making networking gear and it's not interoperable with other vendors, like, you're just kind of shooting yourself in the foot, because there's so much, like, from what I've seen, like, that's like really desirable to have kind of plug and play routers that aren't dependent on a lot of other factors. But that's something you could do with an optional path attribute, is make it mandatory instead of discretionary in the context of your own optional path attribute. Okay, so I think I understand local preference, and I understand it to be the equivalent of a multi-exit discriminator. The difference is that it's well known. It has to be included in every implementation of BGP, and it's but it is similar in the fact that it is discretionary. You can include it or not include it in your update messages. Okay, so let's go ahead and yep. So there we go. We've got oops. Okay, so we've got this. Okay, yeah, so let's try to find a local preference packet. So we're not going to find it in eBGP connections, because this is basically the equivalent of a multi-exit discriminator, but it's meant to be used internal to an operating system, to a, not an operating system, to a autonomous system. Okay, so if I scroll down, now remember, so I'm going to draw the MED first, so we can see a clear comparison between the two. So here I have a AS of 1
and then here I have an AS of 2. I've got a router in each, and then I've got 2 links between the two, so I can send a MED value from this router, we'll call it R1, over to this router, we'll call it R2, and then when traffic is sent from AS2 to AS1, to a route sent to AS2 from AS1 through this router, that route will be given an MED value if router 1 is configured to do that. And it will use that MED value to choose one of these links. So if this link has an MED value of 1 and this has an MED value of 100, it will send it through the lower numbered link. So that is different than how the local preference works. When we're talking about a local preference, oops, and I guess this wasn't too visible. Apologize for that. Okay, there we go. Okay, and that's different than how a local preference works. So this is how a multi-exit discriminator works. You send it to another autonomous system, kind of like you would, you know, I would have 2 hands out for you to shake my hand, and that's just a fact of how I was standing. And then to send you a multi-exit discriminator, I would say, shake my right hand, please. And then you would know to shake your right hand. So that's how a multi-exit discriminator works. A local preference works completely different, although it's basically meant to do the same thing. Just inside your single autonomous system, you've got multiple routers, and you've got 2 BGP paths you could use. So then your route is going to have a local preference, and that's how it will choose between the 2 links internal to a single AS. It will use the local preference value. It won't use the MED value. So that's the main difference. Let's get a local preference value in Wireshark. Okay, so to do that, I'm going to need to change the config quite a bit. I hope they approve my errata. That would be cool. I wrote an RFC. I wrote the RFC on BGP, at least 1 word in it. And if they reject it, hopefully they'll provide a better explanation of that, because that appears to have confused a lot of people. Enough so that somebody else submitted an errata related to that. Okay, so let's do, let's see here. So yeah, let's make it an iBGP connection, and then let's exchange the routes using and include the local preference path attribute. So let's try that. Let's try that right now, because we'll see that because I don't think it'll work if I do it that way. So I'm not sure how to include a. Okay, so I can include it here. So we'll set the local preference to 999, so it sticks out, and then we'll commit that. Okay, and now, well, it looks like we didn't get any sort of update message. So let's set disable the loopback address. Okay, and we'll get an update message that has withdrawn routes in it, but it doesn't have any network layer reachability information. And let's go ahead, let's do it on the other side, so we only get 1 update message. And the reason we'll only get 1 update message
is because, oh, well, we'd have to set up the local preference on the other side. So let's just get the two update messages right now. Oh, and the other thing is, even though we have a local preference, or sorry, a multi-exit discriminator value set up on route 4.4.4.4, that and 44.44.44.44/32, that will not make it so that we only have one update message, because that only happens for routes sent to these BGP routes. When we send our update message, we're sending it to the neighbor address. So the neighbor address is here. So if I do a show route on that, the neighbor address is not even a BGP route. It has no concept of the multi-exit discriminator. It's a directly connected route, which is its own kind of route. So even if I were to go and, so if I take a look at the routing table, protocol BGP, oops. Oh, right, because I shut this down. Let's finish this thought here. So let's get our update messages. Okay, so here's our update messages. And sure enough, we don't have a local preference, because local preference is it's an optional discretionary attribute, and it works within an AS, not across an AS. But getting back to the thought here, one thing I really need to break my mind of is the idea that multi-exit discrimination occurs on traffic sent to a BGP peer. It does not. It occurs on traffic sent to a BGP route. So if I were to do show route protocol BGP, I'll have a route now that I no-shut the loopback interface. I'll have two of them, in fact, each route on the loopback interface. Now I can see that it will only, so if I do ping 4.4.4.4, the source IP is going to be this. Yep, we can see that there is 99. But if I change the multi-exit discriminator here back to 10, it would be 10.10.10.1. So let's do that. Okay, so change that. We're going to get a update message here, but it's just going to be overriding that multi-exit discriminator. So we don't need to withdraw it, since we can just override the existing information. Now let's ping again, and we'll see that the source IP is that class A address. There we go. See it. And let's look at our route. And that one is now preferred because it has a lower MED. And that's across autonomous systems. That's eBGP. So the multi-exit discriminator is a optional non-transitive attribute. Okay, so, or non-shareable. It's meant for that direct connect inter-AS communication. It's not meant to go from AS to AS to AS to AS. That would be a transitive or a shareable path attribute, and it would have to be an optional path attribute. Okay, so next is going to be getting that local preference in there. So I'm going to need to change it to be an iBGP connection. So let's do that. There we go. So now let's set it up on the other side. You'll notice I took the lazy way out. I just defined my local AS in the context of this group, and I decided not to change my local AS. That is the default AS if not, if a more specific AS is not given in a more specific hierarchy of the configuration. So I chose local AS 999, even though my global AS is 2. You can specify your local AS on a neighborship level. Or you can specify it for the group, or you can specify it for the whole BGP protocol, or the whole damn device. It's up to you. There's different ways to do it. Okay, so let's see here. So delete protocols, BGP group test. Ah, right. Okay. So edit protocols group. BGP group IBGP 999. Set neighbor. 2. Okay, we're good to go. Perfect. Okay, so now we've got an IBGP connection. So let's take a look at that. We've got a notification here. So it looks like we're still forming the connection. Okay, so now we've got a connection. We've got our update messages. We've got withdrawn routes. Oh, and I'm not exporting any routes, so let's export some routes into IBGP. And it's going to be 600. So let's change it to 2999. Okay, and then I will delete this as well. Okay, and then we'll change this to match. Okay. Okay. Perfect. Oh, I forgot to export it. And it's going to be, yeah. So export to same 999. Okay, and then we'll need to do, we won't need to do the same thing on the other side. We don't have to have the other side populate. Okay, so we've got our routes now. We can see some big differences. In fact, let's go back and yeah. So here's from before. So let's take a look at the differences between these two. We'll even do a diff using Notepad++. Oh, looks like we've got a lot of differences here. Okay, so if I did a diff, I think every line would be different because we've got timestamps there. So you can see now we don't have an AS path anymore because it didn't traverse AS's. It's an iBGP, so no AS path. We also don't have an MED anymore, and that's because we don't have that configured. That's one thing I want to try is adding that in there. Now you'll notice that we had a local preference already, which is interesting because I didn't see that in. Now this is interesting too. It looks like the iBGP packets are in yellow here. The update messages for iBGP are in yellow, but the update messages for eBGP are in red. That's nice. I like that. But what we can do is filter out for this type here. So we'll do apply as filter selected. And now we can see very clearly our update messages for eBGP are in red. For iBGP, they're in yellow. I really like that. Okay, so now we've got our local preference value being sent in the message now that it's iBGP. So for all of these iBGP, let's add another. Yeah, let's add it where there's a path attribute length. So we'll do apply as filter. Oh, but that's where. Here we go. So we'll apply a filter where the withdrawn routes attribute length, or field length rather, sorry. The field that gives you the length of the withdrawn routes field has a value of 0. We'll apply a filter where that is the case, in addition to the filter where we only see BGP updates. Okay, so now we only have update messages that have, I guess we also have withdrawn routes messages that don't have, but let's do a filter on routes with with network layer reachability information. Oh, okay, well this is for routes with specific network layer reachability information. I just wanted to filter out routes that had and did not have network layer reachability information. Okay, so let's do apply as a filter selected, so we're getting all BGP. Let's narrow it down even more than that. We'll do selected updates, and then let's add an additional qualifier where let's have because the origin field is what the hell? This says it's well-known transitive. See, this is what drove me insane. Is let me look at my drawing again. Here we go. So, it took the drawing away. But
Nah, the drawing's gone. But I made that chart that had path attributes and then two branches, well-known and optional, and then each of those, well-known had two more branches. It had mandatory and discretionary, and then optional had transitive and non-transitive. So here we have a well-known transitive path attribute. I thought that well-known attributes were only capable of being mandatory and discretionary. So this is really unclear to me because the RFC said that there were only 4 kinds of path attributes, but here we can see a 5th kind of attribute. We see a well-known transitive attribute, which is a 5th kind of attribute. The 4 kinds of attributes are mandatory well-known path attributes, discretionary well-known path attributes, transitive optional path attributes, and non-transitive optional path attributes. Those are the 4 kinds of path attributes that the RFC says exist, but we can see here there's a 5th kind, a transitive well-known path attribute. Okay, but let's filter out for this type code origin, and that will be a way, if we do an and selected, there. Now we've only got messages with actual NLRI in it, and since the origin field is supposedly a well-known mandatory, as long as there's NLRI, there's going to be that origin field. Although it says it's well-known transitive, but I'm pretty sure it's well-known mandatory. I don't know what that's all about. Okay, and then all of these are similar. It has path attributes. Okay, and we can see our path attributes change quite a bit. Oh, these are all expanded, so let me shrink those down. Okay, so here's our path attributes for iBGP, and you can see the origin is the same, IGP, whether it's iBGP or IGP. That's because we learned that the origin value is basically just a relic. It's just a holdover from earlier times when there was the EGP protocol, but BGP version 4 replaced the EGP protocol, so that field, origin field, just specifies whether or not it came from the EGP protocol, the IGP protocol, or an unknown protocol, but it's always going to come from the IGP protocol because in the version 4 of BGP, they went with that, so that's just a relic. The well-known mandatory fields are, the 2 additional well-known mandatory fields are AS path and next hop. And then we've got a optional non-transitive field here, even though it says, okay, well here's it's correct, optional non-transitive. They have it out of order too. Maybe this is transitive. Wait, yeah, it's out of order. And it's out of order here as well. Why is this marked as... I'm so confused. It's just confusing. Okay, but you can see we've got the multi-exit discriminator included in our final eBGP. When I switch over to iBGP, we don't have that anymore. We have the local preference. And since local preference is a discretionary attribute, I think I can configure it without that. Although I think a specific router, even though it's discretionary, can just choose to always include it. Oh, okay, I didn't change the local preference.
so now let's, oops, I actually changed it on the other side, which isn't going to work because there's no, yeah, there's no routes being learned on this side, so yeah, I did, oh, it looks like I did get an update message though. But you can see the NLRI, oh, what? Oh, but you can see the update message. I think it was just because this connection bounced, because I changed the local preference on it. You can see this is received from the 10 dot source, and I didn't get one from the other side. So I think, yeah, I think this showed up because the connection bounced. But I'm going to roll this back. Connection should bounce again. Right? Is it not bouncing? It's not bouncing. Why is the connection not bouncing? Okay, so that's weird. Oh, it did. Okay, it just took a long time to show up on the capture. Okay, and you can see the local preference was unchanged because I changed it on the wrong side. There was no, on this side there is no network layer reachability information being sent. There's no export statement on this side. So on this side, let's do what I meant to do. Okay, and now we'll get an update message, and we'll see 999 for the value of the local preference discretionary well-known path attribute. Now this is interesting. Looks like we got 2 updates in one. Not sure what that's all about. It looks like it's, yeah, I don't know why that showed up. Yeah, it's just, and it's empty too. It's the same kind of message, but it's just an empty message for some reason. But here it is, the local preference 999. Okay, so that should make it so that it only, if we look at the show protocols, show route protocol BGP, the higher number is preferred. So if I were to ping either of these addresses, and I were to filter it out for ICMP, there we go. Okay, so now if I were to ping this, we can see it's sourcing from the 10 address. If I were to change my local preference for this neighborship to be below 100, 100 is the default, so I need to, let's change it down to 50. And then I were to ping again. Now we can see it's sourcing from the 99 link. So let's look at the route protocol BGP, and we can see the higher preference of 100, which is the default preference, wins, and it sources from the 99 subnet. Okay, so that's all there is to, I mean, that's not all there is. There's a lot, but like how you implement that, it gets really complicated. And what we can do is we can have it per route. So we can say, when I change the local preference, I'm changing the local preference just for this route. But that's where it gets really tricky, and that's what I think causes pass and fail during the. That's where the wheat is separated from the chaff, or whatever. Yeah, I'm definitely chaff in that regard. Or yeah, chaff is the bad thing. I'm the bad thing. I'm the thing that gets tossed out because I. But let me try that actually, because I think if I have a better grasp on that, I can have more gluten. Okay, so what we're going to do is make it so that
the local preference is applied to something other than this neighbor, it's going to be to the actual routes, I think. But let's just kind of poke around a bit. So here we go. Local preference associated with a route. So we can associate our local preference with an actual route instead of with a neighbor. So let's do set then local preference. So we'll set it to 1000. Okay, so now these routes will both have a local preference of 1000, but this is where I can rewrite my policy, and I'll do that in a notepad. Okay, so I can rewrite this policy so that these are in separate route filters. So let's do this. We're going to do configure private, delete policy options. Okay, so that's good. Let me get this going here. Okay, so now let me rewrite this. I'm not going to use a prefix list. I'm going to use a prefix filter. So let's do edit policy options, policy statement, and we'll name the we'll call it send IBGP or send LO0 routes. I think that's a good name for it. And then we'll do set term, and then we'll do 4.4.4. That's the route. We'll do set from route filter for /32 exact. And then we'll do set then local preference 1000. And then I think we can do a then except as well. Or will it overwrite the then? Okay, no, we can have multiple then statements. So if it's, so we're going to, for our policy statement where we send our loopback 0 routes, we've got a term for the route 4.4.4/32 where we match on that route. Then we set the local preference to 1000, and then we set the, and then we accept that route. Let's do the same thing for the other route. Okay, so okay, and for this route we'll set it to 1, and then we'll do a then accept.
Okay, there we go. Okay, well that's weird. Why is that not working the way I expected it to? Oh, okay, I didn't add the export statement. There we go. Okay, so now, and the other thing that's interesting to know is it overrides what you have on the, so you can see display set pipe no more. You can see I'm setting local preference in this policy statement, and then when I export it, it reads the policy statement and applies to the local preference. So one thing that's interesting to know is look, I set it again on the neighbor, but even though that appears lower in the configuration, it still uses this setting in this export statement. So that's I think important to know. We don't see local preference 50 anywhere, even though it appears to be a later action setting that there. But it looks like it inherits the setting from here. It's a setting from a different hierarchy. But I'll just clean up the config and get rid of that. But yeah, now we can see we've got the route 4.4.4.4 with its own local preference, different from the local preference here. So you can see how granular that can be. But the important thing to know, and you can, I think you can do that similarly for the MED. But the important thing to know about the local preference is that it's internal to the autonomous system, and that is different from the MED because that's for in between autonomous systems. It's for an exit from an autonomous system. So let's see here. Okay, I think that's all I would like to do on that for now. I would like to keep reading this. So let's try to get through. Oh God, there's so much. Okay, let's just try to get through a few more sections. So it looks like we're done with the. Let's try to get through all the path attributes. So the aggregator is the final path attribute, and then we're learning about error handling. That's here we're in section 5. Let's get through section 5 and get on to section 6. So section 5.1.6, the second to last section of section 5, is the atomic aggregate path attribute. Atomic aggregate is a well-known discretionary attribute. Cool. So if you're a network vendor, you have to build equipment that knows about the atomic aggregate and can handle it and process it. But if you're configuring a particular router, you don't have to configure your BGP configuration to process or to send the atomic aggregate attribute. If another router sends it, you can just throw it away. You don't have to process it, and you don't have to send it to another router. But you have to be capable of processing or sending it if you choose to do so. When a BGP speaker aggregates several routes for the purpose of advertisement to a particular peer, the AS path of the aggregated route normally includes an AS set formed from the set of ASs from which the aggregate was formed. In many cases, the network administrator can determine if the aggregate can safely be advertised without the AS set and without forming route loops. If an aggregate excludes at least some of the AS numbers present in the AS path of the routes that are aggregated as a result of dropping the AS set. The aggregated route, when advertised to appear, should include the atomic aggregate attribute. A BGP speaker that receives a route with the atomic aggregate attribute should not remove the attribute when propagating the route to other speakers. A speaker that receives a route with the atomic aggregate attribute must not make any NLRI of that route more specific, as defined in 9.1.4 when advertising this route to other BGP speakers. A BGP speaker that receives a route with the atomic aggregate attribute needs to be aware of the fact that the actual path to destinations, as specified in the NLRI of the attribute, while having the loop-free property, may not be the path specified in the AS path attribute of the route. Okay, that's interesting. So it looks like you can send an atomic aggregate that is a supernet that has more specific subnets, and once the decision is made inside the AS, you can actually send it outside of your AS into a new AS, and basically add secret autonomous systems to the traffic that don't show up in the AS path attribute, because it's the AS path for the aggregate, but there's more specific routes that make up the aggregate, and those specific routes may fall outside of a autonomous system. So you can have like secret paths through your autonomous system that communicate with other autonomous systems, and when you send it to another autonomous system, they won't know about those other autonomous systems as long as you send them an atomic aggregate. So I'm actually kind of curious if an atomic aggregate is like commonly considered like a security risk. Oh, thank you. So here is really good language by Mr. Osama. Atomic aggregate is a well-known discretionary attribute. It must be recognized by all BGP implementations, but does not have to exist in all BGP updates. So that's a really clear way to say it. A well-known mandatory attribute must be recognized by all BGP implementations and has to exist in all BGP updates. A well-known discretionary attribute must be recognized by all BGP implementations and does not have to exist in all BGP updates. An optional transitive attribute does not have to be recognized by all BGP implementations and is shareable amongst ASs. An optional non-transitive attribute does not have to be recognized by all BGP implementations and is only shared between two ASs and within an AS, but is not shareable beyond a single AS. That is the most clear way to say that. Okay, and the final one is an aggregator. Aggregator is an optional transitive attribute. Perfect. Okay, that falls into one of those four categories, which may be included in updates that are formed by aggregation. See section 9.2.2.2. A BGP speaker that performs route aggregation may add the aggregator attribute
which shall contain its own AS number and IP address. The IP address should be the same as the BGP identifier of the speaker. Okay, so let's try to get an atomic aggregate showing up, and then let's try to get an aggregator showing up. So I'm not sure how to do that. So let's use the help menu. Okay, here we go. So we've got the BGP aggregate label. Aggregate labels for VPNs. Okay, well, I'm not sure if that's what I want. Okay, I think this is what I want actually. Okay. Oh, here we go. All right, let's try to send an aggregate label. So what we're going to do is just now this is which hierarchy is this? For a list of hierarchy, you include the. Okay. Okay. So here's. Okay. Protocols, BGP, and then we include it under family. So let's try that. Let's do configure private, edit protocols, BGP, group. Yep, and then we'll do set family inet label unicast aggregate label. Okay, and can I just commit that? No, it can't be a blank label. Community. Oh, I'm not in the right mode. Oh, it's not available for unicast. You can only do it under labeled unicast. Aggregate label. Oh. It says it's not mandatory. It says you can execute it. Okay, we'll call it test.
Okay, and I did it on the wrong router. We're only going to see, oh, here we go. We're only going to see this from router 4 because that's the only router where we're sending routes. But if this bounced the connection, we'll see it because it'll have to reform the connection and send the update messages again. I'm craving peanut butter for some reason. I have to go get some after this. I don't have any. Okay, but we can see the path attributes now. So let's put this on the correct router. It's on the wrong router. Okay, and then we can delete the community. Okay, so I think, yeah, that's all there is to it. Now we'll add it on the other side, where it belongs. Okay. So we got an update message because it bounced, but we didn't get any. We don't get any information. An LRI going this way. It only comes this way. So the configuration on here doesn't have anything to apply to. So we don't see anything. So now that I have it on this side, we'll get an update message. Yeah, there it is. Oh, that's the withdrawn because the connection flapped. So we need one more update message here. I don't see it. Should get one more update message coming soon. Maybe the neighborship's not up. Yeah, the neighborship's still inactive, so it's got to come up. Oh, you know what? It's going to stay inactive actually because it's got to be the families have to match, so they're mismatched right now. Okay, let's make the families match. Okay, now we should get an extra update message, and these should go. Those should go into establish soon. Yeah, there we go. What the hell? I don't know what these are. Well, this is definitely not the not what I was looking for. This is brand new. Brand new path attribute. God damn it, I wanted to see that. I thought that would be easier than it is. Yeah, I thought that would be easier. No, I don't see it. I don't see the atomic aggregate path attribute. Okay, well, so much for that. Shouldn't... I'm surprised I don't see, like, a community being passed. Yeah, there's no community. Okay, well, these are obviously not relevant. Why is there no community being passed? Oh, maybe because we're not sending any actual labeled unicast traffic, we're just sending what's in these statements here. Maybe that's it. That's probably it. God damn it. Oh my god. Okay. You know what? I think I'm gonna give up on that. It's just a bit too over my head right now. So the aggregator is an optional transitive attribute which may be included in updates that are formed by aggregation. A BGP speaker that performs route aggregation may add the aggregator attribute, which shall contain its own AS number and IP address. The IP address should be the same as the BGP identifier of the speaker. So any updates that are formed by aggregation will get the aggregator attribute, path attribute, oh god. Okay. The atomic aggregator is different than that, but it's kind of unclear how that is different. So if an aggregate excludes at least some of the AS numbers present in the AS path set of routes that are aggregated as a result of dropping the AS path, the aggregated route, the AS set, the aggregated route, when advertised to the peer, should include the atomic aggregate attribute. So the atomic aggregate attribute is just a complicated, hard to understand attribute. And it should be, okay, it is well-known discretionary. Discretionary attributes will have this should or shall word in it. Yeah, and these will have the, oh, this has the shall word in it, but it doesn't have the discretionary term because I believe that to be errata, and I submitted an errata request for that. But the next top attribute, this has a this is well-known mandatory, so okay. Well, I was expecting to see must in here. Okay, yeah, here we go. So must will show up. Well, I don't know if it works that way. But anyways, yeah, because it depends on what they're talking about, whether should or must shows up. It doesn't depend on what kind of attribute it is. So, yeah, that's it for this section. Next section will be Bgp error handling. Really making a snail's pace through this, but I learned what the MED is in this video, and I learned it really well, and you know, it hasn't even been 3 hours yet. So to really solidly understand what the multi-exit discriminator is, and to a pretty good extent how it works, I obviously need more hands-on practice and just run through drills and stuff to really get it down, to be able to do my retake and get good points on that. But you know, in less than 3 hours to come away with the understanding I have of the MED, I really consider this probably one of my best videos, because I completely understand the MED and how it is different from the local preference, and to some extent how to configure it, but for sure how to read it, how to see it in the table and understand what action will be taken depending on the value in the table. So I think this is probably one of my best videos I've ever done, because of how well I was able to explain the multi-exit discriminator. So hopefully, if anyone's watching this, you I guess I don't know what else to say. I mean, this is, I think, one of the best videos I've ever done in less than 3 hours. I completely got rid of some misconceptions I had and learned for real some concepts of BGP that I wasn't quite understanding. So that's going to be the end of this video. The next video in this wild networking series will be continuing with the RFC, starting with section 6.